Hi all, today I will solve some problems in real analysis using the Archimedean property of real numbers. So, using the Archimedean property of R, we can see that for any choice of a small real number x, there exists a natural number n, which can be chosen to be larger than x. A necessary consequence of that is that the inverse of such an n, 1 over n, will be less than any real number, which may be denoted by y. Now there is one exercise 1.4.4 in Stephen Abbott's understanding analysis which requires the proof that the infimum of 1 over n such that small n belongs to natural numbers is 0. We're going to use the Archimedean property to prove this. So for example, we have a set A, which is defined as a set of 1 over n of all values of n belonging to the natural numbers, which is 1 and up to infinity. So visually we can see on a line that as the value of n increases, the size of 1 over n decreases, so much so that it approaches 0. Now the theorem is that the infimum of this set A is 0, and we're going to use proof by contradiction. So for the purpose of contradiction, let's assume that the assertion that the infimum of A is not equal to 0. We already know from the way we've defined n such that n is always greater than 0 that necessarily 1 over n is also greater than 0. So infimum of A is not equal to 0 and it cannot be less than 0. This leaves us with just one possibility, which is that the infimum of A is greater than 0. So let's call the infimum of A C, and let's assume that C is greater than 0. So know that for all real numbers, we can find a natural number such that 1 over n is less than that real number by the Archimedean principle. Being that C is also a real number, there has to be a 1 over small n which is less than C by the Archimedean principle. But at the same time, we've said that C is the infimum of n, and therefore no 1 over n can be C, and this is a contradiction. Therefore, by contradiction, we have to accept that the infimum of A cannot be greater than 0. We already know that the infimum of A cannot be less than 0. Therefore, that leaves us with just this one possibility, that the infimum of A equals 0. Just a small disclaimer, because I'm not a professional mathematician, this is an amateur attempt, and certainly there will be errors in use of notation, and possibly even the logic may not be flawless.